Okay, today we're going to talk about lifetimes and resources. So first, you're going to ask, what is a resource? A resource is really any item of limited availability in your computer. So here we're mostly looking at like files and variables, but in terms of the physical part of your computer, that's really like the memory. You know, there's a limited amount of memory in your computer, so you can have a limited number of variables. So lifetimes and rules. So regarding a variable, what is its lifetime? Its lifetime is after you create it and before you destroy it, which I think makes pretty intuitive sense. So you create a variable, and then it's during its lifetime, and at the end of its lifetime, you're going to destroy it. That is the only time when it is appropriate to access the value of that variable. If you attempt to access the value of that variable before you create it or after you destroy it, a few things could happen in your program. Well, one, your program could crash because it's trying to access something that's no longer there. Two, it could work as you expect. It's unlikely, but it is possible. And three, it could not crash, but also not do what you expect. So you have to be very careful of this. Pointers and references to a given variable do not change the lifetime of the variable. They do not change the lifetime. So you need to make sure that the lifetime of the pointer and or reference is completely contained by the lifetime of the object it's referencing or pointing to. Otherwise, you could accidentally dereference a pointer, say, after a variable is destroyed, and that would, as we discussed, cause bad things to happen. So we're going to look at a few examples. All the variables here that we're looking at are color-coded, and on the left you can see the stars where they're created and the axis where they're destroyed. So this global variable, sumGlobal, is created here at the top, and you'll notice it's not destroyed until the very end of the program, or it's not even fully destroyed there. But x here is an argument to the function squareIfEven. So you'll notice that x is destroyed at this last curly brace. Variables are destroyed at the end of the scope they're created in, and scopes are defined by curly braces, if you remember from a few videos ago. So if you create a function, or if you create a local variable within a function, it's going to be destroyed at the end of that function, like we see here with result. Result is declared here, and it's going to be destroyed here. So we can still use x within this function, and then we can create a new variable, and then we can assign this variable to result, which works just fine, and then squared x is destroyed, and then we're going to return the value of result, and this works fine. And then here in main, we're going to set y equal to some global variable, and then we're going to call this function on y, and we're going to print out the value of this function. This works just fine. Let's look at something that doesn't work. This is a function called bad lifetime, and it's returning a pointer to an int. Notice the star, it's a pointer to an int. Here it creates a local integer x, and then it's going to return the address of, notice ampersand is the address of, it's returning a pointer here to x. So the problem is that at the end of scope here, at this curly brace, x is destroyed, but the pointer lives longer than x. So somewhere else in your code, now that you're using bad lifetime, you're going to try and dereference this pointer. You're going to try and dereference this returned value, and you could very well get an error like what we discussed. It could cause something bad to happen in your code because x is no longer there, but you still have the address of x, and you're still going to try to access that address when nothing is there. Let's look at a little bit bigger example. We have a function up here called compare, which once again returns an integer pointer. Notice the star, it's an integer pointer, and it takes in two integer pointers, x and y. So it's going to compare the dereferenced values. It's going to compare, the actual value, whatever it's pointing to, and if x is greater, it's going to return the pointer x. Note, remember, x is a pointer, not the value, and then otherwise it's going to return the pointer y. And then what you'll know is that the pointers here are destroyed, but the dereference values are not. So this actually is fine, because later on we can dereference this returned value, and we'll be fine because the actual values are still going to be somewhere here in main, and we'll see that in a second. So we'll create a array of values, of integers here. We're going to create a pointer to the first value. So we're going to create a pointer here. And then in here, we're going to compare all of these. So you're going to see that when you compare, max pointer's lifetime is now going to be equal to the lifetime of either of these two values, right? Whichever one is returned by compare. And that means that you should treat max pointer as if its lifetime is the shortest of these two. Now in this case, they're the same, right? Because they're both values. They both stem from this array, so it's fine. It's the same as values as we see here. And when we print it out, we're still valid, right? Because values isn't destroyed until the end of main. But in here, what we're doing is we're creating another local, or within this scope, within this if statement, we're creating another variable x. And then we're going to compare that to max pointer. So now you should assume that max pointer's value, or max pointer's lifetime, is tied to x. So when x goes out of scope, you should not try to access max pointer because it could have the value of x depending on this return of compare. So when we go to reference it down here, notice after the curly brace, this is a lifetime violation right here. So it's not something the compiler is going to catch, but it's something you need to be aware of. Obviously, if it's still tied to values, you're not going to get an error, but if it's tied to x, something bad's going to happen because x is out of scope. X is gone, but you're using the address of x here. But when we assign it again to the address of the first value in values, we're fine. We're resetting its lifetime, so we're sure here it's reusable. And then we can print it out with no issues. So remember, you can follow these lines here to see where things are created and destroyed, and you just have to assume that the pointer is tied to the shortest lifetime. And remember here that this guy works. It's a little weird, but that is fine. Now we're going to look at another bad example here. This one, we have a function which returns a reference to an integer called dangling reference. We create a local variable x, and then we're going to return x. But since it returns a reference, we're implicitly creating a reference to x. But when x is destroyed at this curly brace, because x goes out of scope, we now still have the address of x that can be used somewhere else in our program, which is not good, because when we try to reference that, when we try to actually use the value at that address, something bad could happen because x has gone out of scope. So that's it with lifetimes and resources. We'll see you in the next video.